Welcome to physics, and we are required to calculate the height h and also determine the speed of the stone and as it reaches a specific height. So that's the height there at point A, and then we have speed and then angle of inclination and also the time it takes for it to reach a particular position. So we're required to find height, which is h of the cliff. Now what we have to do, let's write down the given information. So initial height is 0, that's ground level. Let's just write it, the initial height is 0, and then we have the 0 meter, and then we have initial speed, that is 42 meter per second. So that's the speed that we have, initial speed. And then we have the initial angle, which is given there, that's 60 degrees. So our angle is 60 degrees. And then we have time there. Our time given is 5.50 seconds. So that's 5.50 seconds. And then from there, those are the given data. So we're going to plug in different informations depending on the question. So height h of the cliff, height h of the cliff will be our height there. Remember, our height is a function of time. So our height as function of time. So our height as a function of time, which means we're going to look for an equation. So the height is there. It's y, the vertical component, initial height is 0, y is 0, initial height. So multiply plus product of the initial speed multiplied by sine multiplied by time minus a half g time squared. So that's the height as function of time. And then our initial speed there is 0, and then we have our initial height. Our initial speed, which is velocity, is 42,0 meter per second. And then we have to multiply that with sine theta. So our theta is 60 degrees. Okay, 60 degrees there. So we're gonna take sine 60 degrees. Okay, sine 60 degrees. Multiplied by our time is 5.50 seconds, minus, that will be half gravitational acceleration, that's 9.8 meter per second squared, multiplied by time. Our time is 5.50 second, and all that squared. And then we have to simplify. Okay, so we have to simplify that part. That's 42, let's use a calculator. That's 42 multiplied by sine 60 multiplied by 5.50, that's 200.05, that's 200.052. So and then we have to solve that other part. Then that other term will be 5.5 squared, and that's going to multiply by 9.8 divided by 2, that's 1. Let's do it again. 5.50 squared multiplied by 9.8 divided by 2, 148,225. so it's 148,225. and then our height in simplified version is 200.052 minus 148.225. Our answer is 51.8. So that's going to be 51.8 meter. So that's our answer. Okay, so we gotta check on the steps. Step 1, and that's the height as function of time. 2, we write in the equation height as function of time. 3, we substitute the values on the equation. And then 4, we simplify whatever answer we have. And then 5, that's our final answer. And let us move on to the next question. Speed of the stone just before impact at A. So at A, we gotta look at that A there, that's velocity there. So what's our velocity there? Now we have to use the equation which says horizontal. So we need our horizontal speed. horizontal speed, and then we know that horizontal speed Vx is going to be initial speed. Vx, that's going to be initial speed multiplied by cos theta, and all of that. Yeah, so that's a horizontal speed component. Okay, and then from there we have the vertical speed. Remember, the vertical has got an impact of gravitational acceleration, so it's going to be the vertical component with the impact of the acceleration. So that's vertical speed Vy, that's going to be our initial speed multiplied by sine theta, sine of an angle, minus g multiplied by t. Remember, g times t gives you velocity, so the speed will be the square root. Okay, so that's gonna be square root of the vertical speed squared plus the horizontal speed squared plus the vertical speed squared. So that's a v initial velocity multiplied by cos theta squared, that's the horizontal speed, and then plus the, remember, the vertical speed is velocity multiplied by sine minus gt minus product of gt, and all of that also squared. So that's what we got, so that's going to be squared. And then from there we have to simplify further. We look at the values. We have a v initial there, and we have theta given angle, and then we also have the time that is given. That's it. So we fill in the information. So our initial velocity is 42.0 meter per second, and then multiply by cos 60 degrees. Remember, cos 60 degrees is half, so it's gonna be 21 actually. So it's gonna 21 squared plus initial speed, that's 42.0 meter per second, and multiply by sine 60 degrees. Okay, so 60 degrees, and then minus, we have g is 9.8 meter per second squared, and then multiply by, okay, let's just extend that, multiply by time, which is 5.50, and all that squared, time squared, and all that squared. So that's the vertical speed. So initial speed, actually the speed component of the speed, that will be 42 multiplied by cos 60 squared, is 441. So that's going to be 441 plus, so we need to get that part there. That part is going to be 42 times sine 60, that's going to be 36,373 minus, so we have 36, that's 36,373 minus, we need that part there, which is going to be 9.8 multiplied by 9.8 multiplied by 5.5, give us 53.9 minus 53.9, and all of that squared, and that simplifies to we have 36,373 minus 53.9 squared, that will be for 441. Okay, that's going to be 307.20, and then from there we have initial speed v, so square root of 41 plus 307, okay, 441 plus 307.20, squaring root, so squaring that root to give us 27.4 meter per second. So that's our answer for B. Okay, so what we do, we move on to the next question. So the next question is C giving us the maximum height h reached above the ground. Maximum height, that is max, h max, that will be initial x max, that's the vertical speed is 0. Okay, so when it moves the maximum height, the vertical speed becomes 0, but the horizontal speed keeps moving, So let's use the equation. So final speed squared is equals to product of product of initial speed times sine squared minus 2g, the difference of the height final minus initial. Alright, so let's get the information right. So initial is 0, initial height is from the ground level, so it has moved from the ground level going up that side. That's the maximum height. V vertical speed is 0, horizontal speed is unknown. Okay, you can calculate that if you want, but the max height there, that's h, that's what we need to calculate. So we know that the vertical speed as it reaches the top is going to be 0, but the horizontal speed keeps moving, and then from there we have the y, which is the height h. So height is h, and then we have final speed, vertical speed final is 0, and then we can plug in the information. So what we do, we have v final squared is equals to v initial multiplied by sine theta, and all of that squared, minus we have 2g, and then bracket h, because remember that y is 0 0, so y is h. So final speed is 0, and then we have v initial multiplied by sine theta, and all of that squared, okay, minus 2gh. And now we need to solve for h. So solving for h, we will have h is equals initial velocity times sine theta initial, all of that squared, divided by 2g. Now what we have to do, we have to substitute the value. So now we have initial speed, that's going to be 42.0 meter per second, multiplied by sine, so that's sine 60 degrees, and all of that information squared all over 2 multiplied by 9.8 meter per second squared. And then using a calculator, let's see, it's 42 times sine 60, and squaring that 1323 divided by product of 2 times 9.8 give us 67.5. So 67.5 meter. That's our final answer. I hope you enjoyed the problem. If you have any question related to this or other physics problems, don't hesitate to send over, or you can email me on the email provided on the channel. And this is your tutor, Black Adam 5D tutor. So it's Black Adam 5D tutor. And yeah, if you've liked the solution, like the channel, do not forget to subscribe or follow on Facebook. Thank you for watching, and yeah, I highly appreciate your time.